All right. I will hand it over now to Shin Adachi. Shin, take it away.
Yes, thank you. And hi, everybody. This is Shin Adachi with NTT CSIRT, and I'll be moderating this session today. Just one item before we get started. We will be holding Q&A immediately following this presentation in Work Adventure, the virtual social platform. This is the same place you can find our exhibitors and other fun activities. And with that, let's get started. It is my great pleasure to introduce today's presenter. Again, he's speaking again. It's great. Mr. Alexandro Duranoy. He is a core member of various open source projects such as MISP, AIL project, or D4 project, working for Computer Incident Response Center Luxembourg, or as known as CIRCLE. Alexandro, stage is yours.
Thank you, Shan. Thank you very much, and welcome to everyone. It's a great pleasure for me to be here today and to talk about a specific topic that we enjoy at CIRCLE. So first of all, I will talk about something that we have to do as a CSIRT, and the thing that I'm talking about today will be about scanning, internet-wide scanning, and the different things that as a CSIRT we have to do, but we are facing some challenges. And one of the first challenges, and if you are operating a CSIRT, when you have to scan for or find specific vulnerabilities in your infrastructures or in your constituents, you usually rely on scanning from third parties. And sometimes it's difficult for you to find out, okay, at which level the scan is. Do we have the latest data of the scan and so on? So it's one of the most common issue, for the CSIRT. Another issue that we have as a CSIRT is sometimes the scanning is incomplete or at least localized in a different country, even if you have, for example, services in your constituency. So it's very common for scanning services, for example, to wrongly assign the locations of the scanning network and so on. Another thing is if you want to quickly find out new vulnerable machines, new vulnerable devices in your infrastructure or the constituent country and stuff like that, it's becoming more and more difficult because you have to find and to do the complete IPv4 address space scanning, so it might take time and so on. So those kind of things becoming more and more difficult. Another thing that is really difficult too is a lot of scanning, for example, is based on IP addresses, but nowadays a lot of services are based on name. So that means when you do a scanning on IP addresses, you are missing a lot of services or potential vulnerable device too. Because for example, on TLS you have SNI, meaning that you have name-based services. So you need to scan with those names and not with the IP addresses to discover those ones. Another thing that is tough is to discover really active and newly exposed devices that you cannot find quickly if you do kind of exhaustive search on all the IPv4 space, or you cannot even find the IPv6 space. So today what I want to do with you is really to discuss strategies on how to improve that. And really the thing that I want to show to you is basically to summarize the technique that we discovered, that we tested, we tried at CIRCLE, and that we are nowadays using to find out those vulnerable machines. I will mention some of the techniques, their advantages, disadvantages, because not everything is coming with like perfect solutions, but sometimes you have to find a right balance between finding quickly devices and, for example, having less resources to be used when doing the scanning and so on. So obviously the technique I will mention today are not an exhaustive list of all the techniques available, but I will cover the most, I would say, applicable strategies for a CSIRT without going into complex or at least pretty large solutions. So to give you a quick overview of what we will discuss is the different techniques that we will show today are basically different ones. So it's not a single one, and you will see that those different techniques are interlinked between each other. So I will talk about certificate transparency, which is a source or data source of information that you can use for finding vulnerable machines. I will talk about, for example, passive DNS data stream and specific techniques that you can, or even trick that you can use to find out that. You'll see that some of the tricks that we are using to find out and scan some new networks and so on are always going back to specific techniques. And on this diagram, and the slides are available and are shared to everyone, you'll see that, for example, one of the techniques, which is basically the brute forcing of DNS records and so on, is I would say, a kind of recursive technique that is used in all the different places. So usually what you will see for scanning, it's a combination of all those different techniques together to find out vulnerable devices, new IPv6 ranges, new IPv6 addresses, and so on, by using those different techniques. So the first one I want to talk to you, and I think this one is maybe familiar for you, it's the certificate transparency. So the majority of certificate authorities nowadays are publishing a kind of logbook, and this logbook contains a continuous stream of all the logs from the certificate being signed and so on, which is a very interesting sources of information. A lot of people, for example, are using that for discovering phishing, a new setup website of phishing and so on. In our case here, we will use it as a source of information to potentially scan new and discover new services to be scanned. First, and I think this one is quite important, when you get access to certificate transparency list, you have different open source tools where you can basically get such kind of information. You have even public accessible services for the logbooks. Thing that you have to do is basically to extract the X509 certificates. So those certificates are published in their format in the certificate transparency. And what we are doing for finding new services and to, for example, feed our scanning mechanism, we are extracting all the subject name from the certificate. So it means that all the records that are used for the certificate. And what we do, we basically brute force and we resolve all the records. So the A records, the quadruple A record to find the IPv6 associated addresses and the IPv4 address associated to those subject names. For each of the host names, so we do that. What we do too is automatically when we record and get that record, we have this IP addresses, we store it in a kind of last-in database. So for us, it's I think quite efficient because a lot of recurring lookup is giving the same IP addresses. So you don't want to scan again the same IP addresses. So you have to differentiate IP addresses that are newly discovered from the one that has already been seen. So we have a kind of quick lookup on that. If you're interested on how we are doing it, even the script that we use for doing that is part of one of our projects. It's called CSIRT, where we have a CTDNS resolver Python script, which is basically doing the resolving of those things. And then we feed those new IP addresses to the scanner, and the scanner will scan. There are some drawbacks to this solution, and that's something to keep in mind. When you do such kind of things, when you have a certificate transparency issue, so when you have your certificate issue, it doesn't mean that the final services is already set up and running on the remote host. So you have to keep that in mind for your scanner activity. So that means you have to keep back those kind of IP addresses for a specific period of time and retry multiple times, sometimes to access. So what you have seen is usually in a period of like 48 hours, 72 hours, you might have different services popping up on the machines after certificate has been set up, which makes sense because system administrators usually set up a self-certificate and then later on they give to a third parties, another organizations, another team, someone else is doing the setup, and they are providing this kind of things. So you see that the certificate transparency is one of the interesting sources of information for your scanner. So you can really brute force all the A and quadruple A records to get IPv4 and IPv6 address space to scan and find quickly potential vulnerable machines on the internet. Another thing that is interesting too is when you extract those kind of host name and domain resolution that you have from certificate transparency, you might do an additional step. And this one is a step that is done very often in finding actively new hosts and so on, is to basically brute force the host name. So how does it work? It's very straightforward. So we will append to a specific domain name, specific host name, and some additional host name that could be resolvable. So for doing that, you have different strategies. I mean, for what we do on our site, it's very simple. We have kind of top 20 host name that we use. For example, www is one, mail, server, and others are used. And then you can automatically find out additional machines that are maybe on the same domain and so on. Be very careful because the brute force activities, when you are brute forcing DNS, it can be slow. So if you enumerate, for example, a complete dictionary, which is pretty large, it might take a lot of time. So usually you have to find the right balance between the brute forcing of the DNS versus the time that you have to have the answer. So what we do usually for having a very quick resolution is to have a top 20. So we have a top 20 of domain names with those kind of additional hosts that we append to the domain names. And those ones are the most commonly used that we have seen, for example, in the passive DNS. We might have a regional one, because in some countries you might have, for example, server expressed in French, for example, or server expressed in English, for example, in different countries. So depending on the country you are in, you might have a different way of doing that. But sometimes you want to go a bit further. So you want to brute force much more hosts, but you still want to have a kind of efficient space for that. So some years ago, we did work with another university on that, and we have an advanced technique called DNS brute forcer, which is DBF, and we're using Markov chain models for that and to recover additional host names. So it's one strategy. Again, this kind of brute forcing of host name is really a key element in your chain of discovering potential new IP addresses and so on, because you have sometimes just a new domain and you have to brute force the associated host name for that specific domain. So that's one common way of doing it. So the thing is, when you find specific IPv6 addresses, you get an additional information. So if you know that a specific IPv6 address is used, it means that the IPv6 associated subnet is active, because this one is routable, accessible to third parties, and so on. So what you can do there, you can get an additional brute forcing on the IPv6 address, because the IPv6 space is pretty large. But if you end up with having just a subnet that you know that is already used, because you get an IP addresses in that subnet, you can do what we call brute forcing of the IPv6 manual allocations. So it means that you will use some specific trick to discover those IPv6 addresses. One of the most commonly tricks is to use the compressed IPv6 address, because when address is pretty large, it's difficult to remember those, but a lot of operators are setting up routers, infrastructures, backend infrastructures on very compressed IPv6 address. So that means if you get a subnet, just write the first entries on those kind of subnet, and you will get some response. So usually it's like even between 10 or 20%, so it's quite important. Additional one is if you have manual allocations, usually it's a human setting up the allocation. So that means they are using a specific X block, for example, hexadecimal block that they can remember. And it's not uncommon to see, for example, blocks like det, beef, ABBA, cafe, quadruple F, and stuff like that, because those ones are easy to remember, and you have, for example, subnet where you have like det 4 times in the hexadecimal representation of the address. So you can just brute force that to discover additional IP addresses. Another thing that we have seen, and this one is pretty common, some of the final part of the IPv6 address contains the service itself. So that means the TCP or UDP port associated to the specific services. So it's a very easy way to brute force manual allocations. Nevertheless, manual allocation is just a part of the IPv6 address space. And the thing is, you have a lot of randomized IPv6 address, which is a thing quite nice because it means that it's difficult to track down user and so on, but for scanning, it's becoming difficult too. On the screen that you can see now, it's a result of just an extraction for the IPv6 addresses I've seen on the CIRCLLU website. And it's just to give you an idea of how many IPv6 are randomized nowadays. And you see that around 85% of the IPv6 addresses are reaching out the CIRCLLU website on one day are randomized. So it's quite a significant number. So it's not like a small percentage. So that means a lot of those IPv6 addresses are randomized. So meaning that if you want to scan those, good luck. It's much more difficult. Nevertheless, you can see that you still have some lower percentage of IPv6 addresses there, which are what we call low bytes. Things like, for example, crawlers and things like that are using those kind of non-randomized IPv6 addresses because they are manually allocated. So that means those ones are easy to scan or discover. So it's again a nice data set to discover which one you need to scan. Nevertheless, there's something interesting here. I was using basically the log entries of my web server to find out those randomized IPv6 addresses. So it might give an idea then for you. It might give an idea of how to collect those randomized IPv6 addresses. If you have a public web services, it's a nice way to basically get all those IPv6 addresses to scan. And that's another trick that you can do. Some security operators are running public services, web services, even network services, for example, DNS, NTP services, STUN, whatever. And they're using that as a source of scanning. So it's not uncommon. Sometimes when you reach out the public services, you are scanned back. And that's one of the effects. So it's another way to find out new IPv6 addresses that you can use for scanning, new one that has been set up. There's another trick, for example, and some are doing that. They are using BitTorrent trackers. So as you know, how does it work for BitTorrent? When you are a BitTorrent client, you need to connect to a tracker to basically say to the swarm of clients that you have such kind of blocks there. But in the BitTorrent protocol, you have what we call the get peers request. So that means if you connect to a specific torrent that are in a tracker, you can ask for all the IPv6 addresses that you get. So you have this what's called N6 request. So it was introduced some years ago, but it's giving all back to all the IPv6 addresses. So it's another way to scan IPv6 addresses because those are active, functional, and are even used to see the torrent currently. So it's one way of getting information. And you see that such kind of things is, I think, easy to set up. There is no big deal with that one. And if you want to have a source of randomized IPv6 addresses, it's one way to do it. If you're interested in the topic of the BitTorrent tracker, there's a very good paper on the university in UK, and this thesis is about analysis of bandwidth attacks in BitTorrent swarm. It's giving a lot of details about the protocol and so on, and you see that there are a lot of opportunities there to collect information. Another thing that is interesting too for bootstrapping a scan and to have really a regional scan is to start with a complete dump of the reverse PTR of the IPv4 space. So as you know, IPv4 is 2 power 32. So that means you can enumerate all the IP addresses, but you can enumerate the reverse entry in the DNS for all those IP addresses. And if you do that, then it's very interesting because you can find out a lot of associated domain names for an IP addresses in specific namespace or CIDR block, which are, for example, allocated in other countries. So it's one way to find out if, for example, some IPv4 addresses that are located, for example, in US should be, for example, located in Russia, and you have a block of IP addresses where you have, for example, .ru domain there. So it's one way to at least, for example, when you do scan, to make more regional scan based on reverse PTR address. So it's one way to do that. Additionally, it's again a nice sources of information to bootstrap your DNS brute forcer to extract the domain names and so on, and again to do the same job than before, like the city log that you were analyzing before, to extract all those IPv6 addresses and IPv4 addresses, and again to scan those and feed those to your scanner. So the IPv4 reverse space is very interesting. It's giving a lot of insight there about the reallocation sometimes of some subnet, even if the WIS entry, for example, from the regional registry is incorrect. Another thing that is, I think, quite interesting, and nowadays that we are doing quite a lot of people are deploying services on GitHub, for example, and other services too, not only GitHub, but GitLab and some others. And many of those provide a public stream of all the project that has been committed and so on. So it's giving you a real gold mine of potential of name there, because you basically have the commits, you have the source code, and a lot of organizations, for example, are testing in pre-productions on GitHub, pushing code, and then you end up with having hostname there. So you can find there potential vulnerable devices, misconfigured devices, and things like that. So I mean, if you are a defender, it's very good to do it because at the end, attackers are doing it too. We have seen that we did some tests where we were pushing information into GitHub and so on, and some host name were scanned by a third party. So in any case, it's good to do it. And for doing that, we have a small library that I developed some years ago called Domain Classifier. This one is really simple, but it's I think one way to divide and conquer such kind of data is automatically extracting all the potential host name and generating IPv6, doing DNS lookup and so on, and then you can find out the real host name and the associated IPv6 addresses and so on. So it's one way, it's a very good source, and you can do that with any unstructured data sources, I mean, social networks, forum, and so on. And it's one way, it's another way to scan not a complete space that you want to find vulnerable machine, but just already looking at host names that are being recently published in GitHub, for example. Another thing, and it's quite interesting too, there are some providers providing what they call the newly registered domain list. So it's a list of all those new domains that has been registered. Some are accessible through ICANN, so they have a program called CSIRT, which is providing an access. You can register, ask for entries, and you will get the entries of specific TLD. Not all of them. So I mean, for example, some country-specific TLD are not providing such kind of stream, which is, for example, the case in Luxembourg. But so it's sometimes difficult to get that. If you purchase a feed from some vendors, it's existing, but it can be very costly. Another strategy there is to use passive DNS stream, because passive DNS contains newly registered domains indirectly because people start to query those. And in addition to that, you have already IPv4 and IPv6 addresses associated to the record, which is giving a very nice source for scanning and so on. So that's another way of finding the active scanning. Another way to do it is to look at the BGP monitoring aspect. So when you need to scan, sometimes you basically scan the whole internet, but it's not so efficient. Sometimes you just want to scan, for example, things that are very recent, which are unstable, because some unstable networks are in currently setup mode and stuff like that, because you can prioritize the scanning on networks that have the highest probability of having vulnerable machine and so on that you can notify. So monitoring BGP message is very interesting. You can find new CSIRT block announced in IPv6 and IPv4, so that's quite interesting. You don't need to have a complete BGP setup for doing that. RIPE is providing a very nice feature called the Routing Information Service Live feed, which is like a complete feed of all their BGP sensors they have around the world, and you get all the messages coming there. So it's a very nice sources, and this one has a lot of potential for finding out new networks and so on, especially in stable one and so on. It's a very good source for doing that such kind of thing. In addition to what we do and what we did for some past year, it's analyzing the network telescope aspect. So if you have a network telescope, you have gathering unsolicited those network traffic, and you can analyze everything that you get out of that. For example, sometimes you get DNS requests that are interesting to, again, do scanning back, things like that. You can even do IPv6 extractions out of some GRE packet that are sent in IPv4, so it's sometimes giving some interesting things. Another thing that is interesting too, if you see, for example, some specific source IP addresses ending in your black hole, like, for example, scanning SSH, scanning RDP, and things like that, it's already giving a huge insight to you that, okay, those source IP addresses are very interesting. So you can use those lists as a kind of priority mechanism for scanning. So instead of scanning, again, sequentially, you can reorder your scan based on the different sources that you see on your black hole. The only drawback for this solution, and we have seen that for the past year, the volume of newly IPv6 addresses seen and so on is very low. So it's an interesting source. You might find very interesting hosts, but it's not a constant stream like the certificate transparency where you see a lot of entries popping up and so on. So that's basically it for me for the introduction of the active scanning techniques. The goal of the presentation of today is really to bootstrap a kind of GitHub account where we will list all the techniques that we know about for the active scanning. As I said, not exhaustive there, so maybe some of the techniques are missing, some techniques are maybe not really applicable for you and so on. So don't hesitate to go to the GitHub repository. We'll add some Markdown document there with the different things. The slides are available there and some additional references. So if you have any question and answer, I will be more than happy to answer you today. Thank you.
Thank you very much, Alexandro. The great presentation and on time, without any time warnings. You're great. And I have to tell you, but if you have any questions, you can find Alexandro in the work adventure in the Q&A rooms, the work adventure place. So again, thank you very much, Alexandro, and
thank you.
Great to have you. So let us prepare for the next session.
Mr. and Lena, welcome, and you're welcome to go ahead and throw up your slides, please.
Great. Oh, thank you for coming. And I am just quickly, I'm going after sponsor that, and after Chris, give me a green light, I will introduce you both and just briefly, and I'll let you run your presentation. And I am going to give you time warnings, 3 minutes before the end, and the absolute time up. So these are the only 2 interruptions I'm going to interrupt you. And
Shin, we're actually ready to go. We don't have a video in between, so you can go ahead and make your introductions. Thank you.
Okay, great, thank you. So let's get us started. But okay, so is this already on live?
Yes, we are. It's just continuous.
Oh, all right. Thank you for your patience, and welcome back to the next section. Again, my name is Shin Adachi with NTT CSIRT, and I will be moderating this session. And just one item before we get started. We'll be holding Q&A immediately following this presentation in Work Adventure. Basically, the same place where social event is happening right after this. So if you have any questions, go there and find the speakers, great speakers. And with that, let's get started. It's my great pleasure to have 2 distinguished speakers, both from ANSI CSIRT France. And bear with me if I couldn't pronounce your name correctly, but Lena, she is a situational awareness analyst within the incident response unit for ANSI CSIRT. And Esther, she is a cyber defense operation manager at ANSI CSIRT. Thanks, both ladies. Floor is yours.
Thank you, Shin. Hello, everyone. I hope you can hear us well. It's an honor to be presenting today at the FIRSTCON 2021. So as Shin said, I'm a cyber defense operation manager, but I joined first ANSI as a operational situation awareness analyst. And so I will be co-presenting today with Lena.
Yeah, hello everyone. So I'm still a situation awareness analyst, and I've been at ATSI for more than 2 years now, working as that in that position.
We are both very excited about presenting today about integration of an operational situation awareness team to a CSIRT, and we are going to more precisely develop the need for specific missions when scaling up, when getting more mature. So what is operational situation awareness analyst? One might wonder, and I'm going to let Lena develop that point.
So yes, thank you, Esther. Let's start with the core of our presentation, what we're going to talk about, which is operational situation awareness. In this presentation, we'll talk about it as both a mission and a team. And as a mission, we define it as the fact as being able to give a synthetic and analytic picture at any given time of any incident response activity. You'll see in the presentation that in practice, it takes really different formats, and it is used for very diverse and a large panel of incident response activities. What we want to show you today is how it works, how useful it is for a national and governmental sector such as South France. But we also hope that you'll see how it can be applied to any other incident response team, both from the private and the public sectors as well. For our team, well, it was created in 2017. And at the time, Esther will dive a little bit more into it afterwards, South France was reorganizing all of its operational teams and activities. So today we're gonna tackle 3 main points. First, what does the need for creating such a team come from? What it is 4 years later, meaning what we do on a daily basis, who we interact with, and what we do within an incident response team. And finally, the challenges we face building this team and are still facing sometimes. And also we start with the but. Where does it come from? What does that need come from? And the origin of our situation awareness.
Yes, so first thing first, let's get started with the when, the how, and the why it was created. So in order to do that, as Lena told you, I have to take you back to year 2017, when the year when France was reorganizing its operational teams. At that time, situation awareness already existed, but in a different format, in a less developed form in comparison with the current one, as it was partially assigned to a team which main mission was cyber threat intelligence. Now, 2 important reasons for creating a specific team and integrating it to incident response teams are that, first of all, situation awareness was mainly used for major incidents, and at the time it was more a situation report mission than an analysis. Therefore, the associated deliverables were longer and looked more like a situation playbook, which was sufficient until the reorganization. At the time, South France was getting more mature, and the volume of its operational activity was increasing. Some major incidents made it clear that there was a need for easily accessible analysis of a given situation that would serve decision-making for South France leaders and above. It also rapidly turned out that this need for clarity and synthetic vision was not limited to major incidents, but also for the whole incident response chain. Second of all, the cyber threat intelligence situation team was separated de facto from the incident response technical team. And given this separation, situation awareness was de facto scattered among that team and technical experts on the other side, who were facing time-consuming solicitation from the management. So therefore, it was decided to create a team that was fully integrated within the incident response team, It includes technical experts, teams in charge of triage, etc., that would be able to take charge of operational situation awareness for both the all incident response activities and for major incidents. And it was also decided to couple this, couple the situation awareness analysis mission with another one, which is operational activity regulation. So you understand why just after I get you through a little bit about what is operational activities regulation. Okay, so actually this activity was a brand new mission when it was created in 2017. The mission and the objective of this new team is to control the proper and the good running of the incident response chain. Interestingly, until 2019, it was done by operational situation analysts on the best effort mode, and since then the team has been fully staffed. So how do they complete this mission? With various ways, by constantly reviewing alerts received and handled, by the uniformization of incident treatment, by doing a first level transversal analysis with comparing and merging alert incidents, which is of great value for all the teams in the incident response chain. And they also suggest actions like prioritization, escalation within the incident response chain. And so this job, which not existed before, enables really interesting things for South France. As a matter of fact, regulators have a central vision of operational activities, and they can give at any given time a vision of the CSIRT resources engaged in incident response activities and also produce trends. And so this central vision really gives them a hand to support decision making for the head of incident response division and globally South France leaders. And second of all, not only do they have a central vision, but they also have a full operational picture thanks to its position within the incident response chain. And so as such, it is the most capable of identifying and alerting of emerging trends or risky incoming incidents. And so this, the reason why these two missions were created together is because, well, they're complementary, and basically situation awareness analysts and regulators work on a daily basis. And I let Lena tell you a little bit more about that.
So as I've presented you what operational activities regulation is, for the rest of today, we're going to mostly focus on what situation awareness does, but it's important to keep in mind that both missions, even though they are very different, they complement each other very well. What makes them different was situation awareness analysts are working on incidents, and they are actually part of the incident response chain, whereas operational activities regulators are controlling and supervising the incident response chain, ensuring that everything runs smoothly, and mostly they work on how incidents are handled. So both activities are quite complementary to each other in that way.
Just now, a little focus on human resources needed in order to accomplish the mission described. So as you understand, the amount of work behind the mission described earlier really depends on the impacts, but also the volume of incidents notified and handled at South France. So let's just take a look at the volume for year 2020, for instance. These are the numbers you can find in the annual report of, and you have the link on the slide. Lena will tell you a little bit more about these notions and what they stand for what do we understand by major incidents, compare them with incidents or cyber defense operation just after. But what is interesting here is to see that there is a certain and ever-growing amount of security events handled at South France. And so we estimate that in order to tackle the missions we have, it requires 6 situation analysts and 2 or 3 regulations analysts. As for the profile needed to fill these different positions, well, they are quite hybrid. Are needed people who can understand and analyze a very complex and diverse situation and its technical details in a very short time. But generally, people with business intelligence or political science background or engineering and a strong understanding of the cybersecurity elements are needed. Naturally, this pool of candidates is more gender balanced than pure engineering posts, which is, well, something quite rare within the cybersecurity field and thus noteworthy.
Thank you. So now that you understand where we come from, we're going to try to talk a little bit more about what we do on a daily basis, what it actually means to have a situation awareness team integrated to a CSIRT. But before we go into detail, I want to come back to what Esther told you about a little bit. What we call at CSIRT France are treatment modes. In fact, incident response is organized in 2 types of treatment modes according to the nature of the incidents, based on the sensitivity surrounding the victim, but also the level of impact the event has on the information system that is affected. And we talk for the cyber defense operations, which are usually the incidents on the larger scale. What is created is a specific team to which a situation awareness analyst is integrated specifically. For the rest of the treatment modes, alerts, incidents, and major incidents, well, they are treated by the quite classical, I want to say, incident response chain with an escalation process that is put into place when and if necessary. And situation awareness has also a different role for that within that incident response. I'll start by telling you about what we do in cyber defense operations, and after we'll tell you a little bit more about what we do the rest of incident response. First, cyber defense operations. Well, as I mentioned, for this type of events, a specific team is created within CSIRT France, overseen by a team leader, cyber defense operation manager, who operates a matrix management. That team is composed of different experts, such as a forensic coordinator, a CTI specialist, for instance, but also a situation awareness analyst, whose job in that context is to produce 2 types of deliverables. First of all, we produce regular situation analysis reports that are disseminated among operational and management teams within CSIRT France. And given the evolution of the incident, these reports are produced between once a day to once every few weeks. Secondly, we also produce specific situation analysis reports on demand or when relevant that can be shared outside of CSIRT France towards more political authorities or toward partners, both international and national, and sometimes towards our constituents themselves. Esther will tell you a little bit more about what those reports look like. But what's important to understand is that they are quite thorough and they try to cover a large spectrum of topics, as large as possible, meaning and they contain forensic results, investigation on the attacker's infrastructures and motives, recovery efforts, relationship with the constituents, and some partners or third parties if they are some, risk analysis, etc. And the goal is, with all of that, to still give a synthetic picture of the incident and its treatment within CSIRT France, while giving a broad understanding of the technical elements. So that's what we try to do for cyber defense operations.
Okay, so besides cyber defense operation, situation awareness is involved in the incident response chain from alerts to major incidents. And so these events, which represent the large majority of what is handled by South France, go up to the incident response chain after a classic. There, the situation awareness team is mobilized to give a synthetic picture of the whole incident response activities of South France, analyzing ongoing trends and point out emerging ones. For this mission, situation awareness works closely with operational activity regulation. So as we mentioned earlier, we are very complementary. For this mission, we also use, for instance, a matrix as a specific tool, as you can see on the bottom right hand side of the slide. And this matrix represents the volume of security events depending on the one axis victimology, and on the other one, the level of impact on the information system targeted. And this tool is very useful for us to have a visual and global picture of what has been going on. It's very easy to compare one situation on different timeframes. For instance, if you want to see what entities have been impacted by a given type of attack, like ransomware, it's easy to see what it looks like as a pattern for year 2020 and year 2019. Moreover, in collaboration with operational regulation, situation awareness is in charge of producing statistics and indicators related to incident response activities. And finally, similar situation analysis reports as the one produced for cyber defense operation can be produced for incidents when relevant and major incidents quite systematically. So now I'm going to show you what situation reports look like. So it's an example. Of course, we cannot show you a full situation analysis report. So this example contains fake text and fake people examples. What is key here to remember is that situation analysis reports are usually read by people in charge, management team, in order to support their decision making. In our case, as Lena told you, ANSI leaders, authorities sometimes. Thus, in a nutshell, people who don't have much time to read. So it is paramount that situation reports are built a way readers can access easily and quickly, in a glance, key information for decision making. And so in this example, so on the left page on the slide, you can see key information such as what are we talking about, what type of incident is it, what entity is targeted, what are the stakeholders, what is the level of risk associated with this incident. You can also have information very quickly of where are we in terms of investigation, are we engaging action in remediation actions or not. Of course, you have an executive summary of what has been going on. You have what is new about the situation, the operational situation. You have a list of appendix, etc. Of course, between these two pages, the one on the left and the right, in general, you have others with details, but it's best short. On the right page, so you have different examples of visual elements produced, like timelines, like diagrams. So it can be a timeline of the attack, what we understood about the attack. It can be a timeline about the cyber operation itself. But basically, everything is done so that the readers have very easy accessible information, make decision, or just to know where to go in terms of investigation. This slide here is about giving you an overview, a summary of what we discussed before. Basically, you have so the treatment modes that Lena presented to you, and on the right you have the different situation missions that situation analysts are doing. So you can see there is the reports, you have statistics, the trends, and the regular operational picture. That is a mission itself of situational awareness.
And so you've seen that situational awareness is part of the whole incident response chain. But actually with those missions, situational awareness holds most cross-level vision of incident response activities in France, with operational activity regulation as well. So what does it do in fact? Well, it's fundamental help for decision making, for prioritization, and it allows for a management of the information that we share towards partner or authorities. However, it's important to keep in mind that situational awareness is not reporting or information management, because in fact it requires to be able to understand and analyze complex technical investigation, to take into account the context, the stakes, the risks, all of it in a very short time, in order to deliver an analysis of the operational situation that is tailored towards the recipients. And those recipients can be the operational teams. For instance, if a new technical expert arrives on the specific incident response, well, those reports can help them understand what they get into. It also, those recipients can be our management that will use them for decision making and prioritization, or political authorities that will use them for more strategic, let's say, decision making. The most difficult part is to tailor the deliverable to the recipient.
All right, and so last but not least, we're going to tell you a little bit more about what are the challenges we face in order to get a fully integrated. So as for the challenges, so when the team was created, of course, challenges arose, which are mission-related challenges, of course, but also human resources challenges. So besides finding the right place for the situation awareness analysts, who are non-technical experts, as we mentioned earlier, finding the place for them among an incident response team, one of the core challenges that mission entails was and remains finding the right amount of technical details to include in the deliverable and how to include them. Indeed, those deliverables must be precise and concise so that France leaders can exploit them for decision making. They also need to give a comprehensive and thorough vision so that incident response team can exploit them in order to keep up with how incidents are progressing and come up with appropriate postures for the treatment to present. As for the human resources challenges, I talked about that a little earlier. Basically, the new challenge we face is how to handle the ever-growing amount of solicitations, which are the price of success, I guess, of how the team has proven itself very useful or indispensable. And of course, there is the challenge about recruiting hybrid and rare profiles, as I described. And now Lena will tell you a bit more about the threshold to face.
Yes. We wanted to finish on that part, particular part, because as a matter of fact, it takes time to build a team that holds such specific missions, such new missions. And there were specific events or thresholds, if we can call them that played a significant role in demonstrating how useful the team was for the whole incident response activities. And here are two examples that can highlight that point. Starting with 2019, when CSIRT was facing particularly complex incidents, And at the time, the situation awareness team was getting bigger.
3 minutes left.
Thank you. The situation awareness team was getting bigger, so situation awareness analysts could prove how useful they could be in that context. Because facing such complexity, well, it turned out that having an analyst that is specifically dedicated to making things clear for everyone, from analyst to management, is quite precious, especially because it allows for incident handlers or forensic coordinators to focus on the core of their work, and organizing and treatment, managing the relationship with the constituents and everything, without worrying about the fact that their management have a clear picture of what's happening. The second threshold is the pandemic, because as a lot of you, I guess, we were able to work partly from home due to the lockdown. And at that particular time, situation awareness and as well operational activities regulation worked for ensuring that there was a continuity in operational activities, because they were instrumental for other incident response teams to keep up with the whole operational activity and the whole picture, to have a clear picture of all of it. It was also key at the time for fulfilling an increased need, an increased demand for reporting and analyzing incidents that specifically targeting the healthcare sector, which became a top one priority for everyone at the time. So that's why that's true example of when situation awareness team became quite important, prove their value. Actually, that's it for us. We remain available if you have questions. And thank you a lot for listening and watching our presentation.
Thank you very much. A great presentation from a great experience, and everything was on time. Thank you. Now, there will be question and answers by these great presenters and social hours at our work adventure, the social platform. So I would like to remind you that go to the work adventure to ask a question to socialize others. And I guess this concludes today's presentation. And thank you for your presentation, and thank you for coming and listening. Have a great day or a great evening, depending upon your location.
Thanks, everyone. See you tomorrow.